Okay, so to do this problem, first thing we need is the balanced equation. Okay, so sodium carbonate. What's sodium? Na with what charge? What's the charge on sodium? Plus one. We know that because it's in group 1A. So it's plus. And then carbonate is one of the common ions that we memorize, but we go and look on the chart and we know carbonate is CO3 with a 2 minus charge. So what's my formula for sodium carbonate? Na2CO3.
Does it matter which side you put it in? Which side?
No. Okay, there is a technical difference. When the sign is at the end, that means that it's an actual ion, that the electrons have been transferred. When the sign is in front, that's the oxidation state, and that's more important in covalent bonding when they're sharing electrons. The electrons are not getting transferred completely, so you're not making ions, but it tells us how many electrons are involved in bonding. That's why some can have more than one oxidation state, a +2, a +4, a +6, because they have varying numbers of electrons that are involved actually in the bonding in covalent. In ionic compounds, the oxidation state and the charge are going to be exactly the same. Okay, so we don't really worry about it much with ions. So, but no, this chart's completely backwards. You'll never lose points for putting the sign -2 versus 2 minus, but there is a technical difference between the two. All right, so it says solution, so I know that that's going to be aqueous, plus silver nitrate. Silver is Ag. Now, you may have to know this one for the AP test, but if you look, silver's in family 11. It's going to tell me it's +1. The group number kind of helps us to know the charge. So those in group 12 are going to be +2. Okay, so that's just a way to kind of remember that. And then nitrate is one that was so common we're going to remember NO3 minus. So it's just AgNO3. Now what type of reaction is this? A double replacement, so they're just going to swap. So sodium's going to go with nitrate, silver's going to go with carbonate. You always write the positive one first. So it doesn't matter which order we go. So we're going to make sodium nitrate. And you balance the charge first. Don't worry about that it's a 2 here. That 2 doesn't necessarily carry. Balance these charges first. We'll balance atoms later with coefficients. Okay? Plus silver carbonate, which would be Ag2CO3. Okay? So now what do we have to do? Coefficient, we have to balance it. So 2 sodiums, 2 sodiums. Okay, that gives me 2 nitrates. So I have to come here, that gives me 2 nitrates. That gives me 2 silvers, I have 2 silvers. The last thing that we have to do on this is determine which one of these is going to be my precipitate. Because in order for there to be a chemical reaction, either a solid, liquid, or a gas has to form something other than aqueous. Now, we have big 3 solubility rules. Anybody remember what they were? We need to remember. Anybody? Remember any one of the 3? To what? All nitrates are soluble. All ammonium compounds, NH4+, are soluble. Anything that has ammonium in it, anything that has nitrate, and then anything that has a group 1 alkaline metal in it, lithium anything, sodium anything. So we know sodium anything is aqueous, nitrate anything is aqueous. So I know that this one is going to be aqueous. And then by process of elimination, since it says a reaction occurs, this has to be my insoluble solid. Now you can also turn around and look at the chart in the back. Okay? If you look at the chart in the back, you'll look under carbonate. Okay? And when you look at carbonate, you'll see, it's down at the very bottom of the left column, that only ammonium and group 1 cations are going to be soluble. Okay? Even lithium carbonate's not. So there's an exception to all alkaline metals are soluble, but okay? Every other cation, third column, every other cation is insoluble. So we'll have that chart up so you can look at that, and you know, so as far as solubility rules are concerned. And so silver is not one of the things in the middle, which means silver carbonate is going to be a precipitate, which means it's going to be solid in the equation. Okay? You're only expected to know all nitrates, all ammonium compounds, all alkaline metals are soluble. That's all you're expected to know. Come reline this up, please. Okay.
Oops, I just,
Stop it.
no, I didn't do it.
You just gotta be super tough on it.